All right, let's grab our notebooks and get ready to learn how to solve separable differential equations. All right, separable differential equations come in two types. Either we can write it as a quotient of f of x over g of y, or a product, f of x times g of y. You'll notice that we had the word separable, and the whole purpose of this is we're going to separate it, and we're going to get the x's on one side and the y's on the other side. So if we look at this first situation, we could do what we usually call cross multiplication. And actually, we usually like our y's on the left. So let's start that over again. So we could write g of y dy and set it equal to f of x dx. And once we've done that, you'll notice all the y's are on the left, the x is on the right, and now we can take the integral of both sides and solve it. On this next one, we can also separate them, but when we do so, we're going to take dy and we're going to divide both sides by g of y. So g of y actually ends up in the denominator, and over here we have f of x dx. So these are two typical examples of what separable equations look like. All right, so let's take a whole problem from start to end. Here we have dy dx equals x over y squared, and we're also given information that when x equals 0, y equals 1. All right, so the first thing we want to do is get our y's on the same side and our x's on the same side, and when we do so, I get y squared dy equals x dx. And we simply multiplied both sides by y squared and both sides by dx. The next step is to integrate both sides, so I'm going to put an integral sign in front of both of these. And the antiderivative of y squared is 1/3 y cubed, and that equals 1/2 x squared. And then we're going to put a plus c over here. Now I'm just going to take a moment to explain why we don't need plus c on both sides. So I'm going to write it over here for a second. So let's say I wrote this. I'd have a constant on this side, and I have 1/2 x squared plus a different constant on that side. Well, I can subtract c1 from both sides. Those cancel, and when I take c2 minus c1, I get this c. All right, so this c over here is the combination of my two constants in just one place. All right, now we can figure out c because we're given initial conditions. So we are told that when x equals 0, so if I put in a 0 here, y equals 1. So I've got 1/3 times 1 cubed. And so c clearly equals 1/3. So now I rewrite this, 1/3 y cubed equals 1/2 x squared plus 1/3. And then typically if we can solve for y, we will. So let's carry on over here. Let's get rid of this old work. All right, and let's see, let's multiply everything by 3. So we'll come up over here, y cubed equals 3/2 x squared plus 1. And the last thing to solve for y, we take the cube root of both sides. And we have our first answer. All right. Let's try another one. In this problem, we see y prime. It is in these problems always important to rewrite this as dy dx. So the first step is to rewrite using dy dx. It'll help us see if we've got our y's and our x's together. And when we do this, I want to divide by y. So I'm going to have dy over y equals 4x cubed dx. I'm ready to integrate both sides. And the antiderivative of dy over y is natural log of the absolute value of y, and that is going to equal x to the 4th plus c. All right, I always like to figure out c right away, so we're going to go ahead and put in x. So let's see, x 0 to the 4th is 0, and over here I have the natural log of 7. So now I'm going to rewrite. I've got the natural log of y equals x to the 4th plus 7. And when I solve for y, remember the inverse of natural log is taking something to the power of e. So I get this. Oops, I made a mistake here. You guys are probably noticing this. Over here, this should have been plus the natural log of 7. Absolute value of 7 is 7, so I don't need to write the absolute value anymore. So let's see, let me step back. So I fixed that up, and now I'm solving for y. And when I solve for y, I am going to write e to the x to the 4th plus ln 7. Now this is a correct answer. Okay, so I just want everyone to know on a free response, this would be a perfectly correct answer. But in the back of the book or on a free multiple choice test, the answer would never be written this way. So I'm going to take 2 steps to do what will become much more natural later on. I'm going to start by rewriting this like this. Remember that when we are adding exponents, or actually when I'm multiplying, I add exponents. So e to the x to the 4th times e to the natural log 7 would be e to the sum of those 2 powers. So I can in the same way go in reverse. And when I write it like this, we know that e to the natural log of 7 is simply 7 because e raised to a power and natural log are inverse operations. So we end up with just 7 e to the x to the 4th. And that is our uh, also a correct answer and a more accepted answer. All right. So at this point is probably a really good time to review the steps. And I'm going to just take these one at a time. So our first step, you'll notice, was that we collected all terms of one variable on one side and all the other terms on the other side. And we do this by multiplying or dividing. So essentially, we put the x's on one side and the y's on the other side. The next step is we integrate both sides with respect to the appropriate variable, and we only put plus c on one side. Step 3, if we are given a set of coordinates, we solve for c. And our last step is we solve for the dependent variable in a situation like dy dx is y. So we solve for y to find our general solution. All right, so here we've got a problem that looks quite a bit more simple, but then sometimes simple things look harder. Just one hinter, we could do dm over 3m equals dx, and we have put the m's together and the x's together, but if I integrate this, I'm just ended up with a u substitution situation, which is messier than it needs to be. So I want to show you a way to avoid it being that hard, and that is to actually just do dm over m equals 3 dx. Now what's nice about this is we know that antiderivative and there's no w substitution involved there. And so I simply get the natural log of m equals, and on this side, 3x plus c. All right, so we can plug in our numbers. We've got the natural log, m is 2, so natural log of 2 equals 3 times 1 plus c, and c equals this lovely number, natural log 2 minus 3. All right, so we go to solve this. We've got the natural log of m equals 3x plus natural log 2 minus 3, and we're going to solve for m. m equals e to the 3x. I'm going to change the order of these. And remember how this could be written as e to the natural log 2, so we would get m equals 2e to the 3x minus 3. All right. This might be a really good one for us to also do a little bit of check on the answer. Does this make sense? I have a value for m here, and let's just check out, does this work? So we're going to do a little check here, and let's figure out what is dm dx. So dm dx equals the derivative of this, which would be 2e to the 3x minus 3 times the derivative of this inside 3, which would equal 6e to the 3x minus 3. Now we were told up here that the derivative is 3 times the function. All right, here's my derivative, and here's my function. Look at that, it's 3 times bigger. So a nice little check to see that it works. All right, so let's look at this problem here. Oops, just jumped around. We're back at this problem. We've got dy dx equals 6x squared over 2y plus cosine y. Take a look at this. Pretty quickly we should see it's a situation where we're going to cross multiply. And then we're ready to integrate both sides. So we'll do that. And we've got y squared plus sine y equals, let's see, 2x cubed plus c. All right, so that's good. I can put in the information. Y of 1 equals pi. So I've got pi squared plus sine pi equals 2 times 1 cubed, so that's just 2, plus c. So let's see, my c is going to equal pi squared plus, let's see, sine of pi is just 0 minus 2. So I rewrite this, and I've got 2, oh, not 2. Sorry, I'm going back to my function here, y squared. So I've got y squared plus sine y equals 2x cubed plus y pi squared minus 2. All right, now if we tried to solve this for y, we get frustrated very quickly. And the whole point of this one is sometimes you can't solve for y. And we've got this little note down here that this differential equation can only be solved implicitly. Now when we say something can only be solved implicitly, that means it's not possible to solve for y. Not possible to or not solve for y. Sometimes we define things implicitly that could be. So it means that it's not solved for y. Not solved for y. Okay, let's take a look at what else we have here. This would be a, well, let's go ahead and just jump into this one. Take a look at how we're going to separate our variables. So we've got dy over y equals dt over 3 plus t. All right, integrate. The left side looks familiar. We've got natural log y. On the right-hand side, it's simply going to be natural log 3 plus t, and I didn't need to do any special w substitution because the derivative of the inside is 1. If I were to take the derivative of this as a good way to check, I would say, oh, okay, 1 over 3 plus t times the derivative of the inside is 1, and yeah, that works just fine. So no extra work there, and I also need my plus c. All right, we'll put in our information. So y is 1, x is 0, and we know that natural log of 1 is 0, so c equals the negative natural log of 3. So now we've got natural log of y equals the natural log of 3 plus t minus natural log 3. All right, so let's try this out. Y equals e to the natural log of 3 plus t minus the natural log of 3. Wait a second. That would equal e to the natural log of 3 plus t divided by e to the natural log of 3, right? Because we're subtracting our exponents, which simply simplifies to 3 plus t over 3. All right, and that's it. There's our answer. All right, we've got one last problem for you here. And in this problem, we've got that y prime. So let's start off by rewriting that as dy dx. We've got this y, x, y minus 1. All right, so right now I have dy on this side. I can keep y minus 1 here. This y I'm going to have to divide by, so it's going to be down here. And on the other side, I'm going to multiply by dx and divide by x. All right, take a look, make sure everything looks all right. Y minus 1 stayed, dy stayed, divided both sides by y, dx we multiplied by, and x we divided by. By the way, dy and dx must always be in the numerator. All right, so we're ready to integrate both sides. And, well, wait a second. How do I integrate this? Well, you should remember I can divide both terms by y. So I've got 1 minus 1 over y dy equals the integral 1 over x dx. All right, so now we're ready. Y minus natural log of y equals the natural log of x plus c. All right, and in this problem we were given no original numbers, so we don't have nothing to plug in, and we can't really solve for y either. So we are just going to leave it as is and call it a day. All right, good luck on your homework.